Welcome to the second part of the video, and in this part I'm going to explain the results, conclusion, and a little bit more about my project. As I've stated earlier, the dual steganography process involves embedding both in transform and spatial domain. The embedding here is performed over selected pixels which are randomly chosen using a random path function. We want to introduce more randomness in this process, which would make it even more difficult for people or miscreants who do not have the key, which is only being shared between the sender and the receiver to find out whether a message has been embedded into the image or not. The randomness here is very important and is also the most attractive, is one of the attractive features of using this image technography process or of embedding both in transform and spatial. Now, for testing our project, we have taken two tests, uh, three different test images. For example, you can see here I'm taking an image of Veena, the JPG, and I'm performing the various steps such as pre-processing, uh, pre-processing here, and finding out the hiding capacities, and performing IWT on both green channels and red channels. And this is where the randomness of this function, this process comes in, wherein we are choosing random paths using a random error generating function, and this random path makes the information more secure. And then we are using the LSP substitution here, and so on. So as explained by the algorithm here, and we are finally calculating the PSNR values of the different channels, and these are the images obtained. As I've shown in the first video, the uh, I've run the code in the first half of the video, and these are the images. It takes some time for to obtain the images. So you can see this is the image which I have given as a test image, and this is the image after embedding. And as you can see, there is not much change in the image quality, uh, which is a brilliant thing for this process because it maintains a good PSNR value. It is good in terms of robustness and image quality. Image quality is very good. As you can see, there is not much difference in both the images, but when you see the pixel sizes, which I mentioned in this, you can clearly see that the pixel before embedding is 5 across 5 in image, and after embedding it is 3085 across 2950 because of including uh, substituting the pixels or including random data into the image. Though the quality has been maintained and the message has been embedded, which is what we sort of. And the same has been done for both the other two test cases, the baboon and the koala, and the various PSNR and the hiding capacity values are graphed. Now, as you can see, there is only a little distortion which you can see in the image quality after the dual embedding process, and only upon very keen observation that you notice that there is some change between the test image and the image after embedding process is done, which validates the method of securing the information over image, which is good. These are the other important results, namely the embedding capacity and PSNR, which actually differentiate this process over a plethora of other techniques, which include constant embedding and embedding in only one transform domain or a spatial domain, etc. As you can see, for three test images we have taken for Lalina and Baboon, the embedding capacity is very good, very good compared to all other processes which are currently being used. For example, LSP substitution, only IWT, uh, adaptive, other adaptive techniques, etc. The embedding capacity of Fola being 1,304,000, Nina being 1,175,000, and Baboon being 1,332,657, and the PSNR being 43.3 for green channel, red channel 42.5, blue channel 33.96, for Lena 43.93, for green channel 43.788 for red channel, and 36.62 for blue channel. As you can see, the PSNR for blue channel is low because blue channel is highly sensitive, and we are only performing IWT on it and not any other operation. As I've told earlier, IWT, though it is better compared to DWT, but it still has less PSNR than we expect. So, and hence you can see the low PSNR of the blue channel. But whereas green channel and red channel have a good PSNR, it is because of the spatial domain transformation which is being made, and also them being of high frequency wavelength, which is good for IWT. IWT is bad for low frequency wavelengths, and thus we ignore even the LL plane. So as you can see, the PSNR values are also good compared to other techniques which are explained in detail in the report. And the conclusion, we have come to an end of the uh, last part of the project. Uh, a dual steganography process was described and implemented. Embedding information into the image has been performed in both spatial as well as transform domains. Data is introduced randomly in the image, and hence both parties, the sender and the receiver, should have the knowledge of the key. Since the paths taken are random, key is very vital for decoding the information. Decoding process is also similar. It is actually basically the reverse of what we are doing here. We first perform the IWT on the blue domain. Then we perform the spatial. Then we use the RNG to perform the spatial domain, and then an IWT is performed on it so as to obtain the information. The MSC and PSNR values have been calculated for the following processes, and results are very much satisfactory, and the memory capacity is also can be better than the current steganographic methods. I would actually want to show you the calculation of the values obtained of the PSNR, the things which I've taken. Here you can see here. The PSNR values are 43.7884, 43.93, and 36.6224, as I have mentioned, and 43.93, 43.74, 36.6224, which are very good compared to the other methods which are being followed currently. So, PSNR values, basically, you can actually see a matrix, but since it is huge, you can't see the values here, but here you can see. So, this concludes the project, and the aim has been satisfied. We have we have performed image technography, and we have found better results, and that's the end of this project and the video. Thanks for watching.